In this video, we're going to look at a couple of situations for applying the law of sines. So for this problem, we want to find the value of x. So in this case, x is the length of a side. Now notice that this is not a right triangle. This would be an oblique triangle. So the law of sines would say the ratio of any side to the sine of its opposite angle is the same for all of those ratios in the triangle. So now if I look at this side with a length of x, I don't have that angle. See, what I have is this angle-side situation. But the angle-side situation, I can always turn it into an angle-side angle. If you remember, that's how we proved that angle-side would work, is because we can always turn it into an angle-side angle. So if I add 59 degrees and 99 degrees, now let's see, 99 is 1 away from 100. So if I add 1 to this, I get 100. Subtract 1 from that, I get 58. So 158. So I'm going to take 180 degrees, subtract 158 degrees. 180, 80, 30, 22 degrees. So the measure of this angle is 22 degrees. So now I have an angle-side angle situation. Okay, so angle-side angle. I can use the law of sines. Now I'm going to use the version of the law of sines where I have the side lengths in the numerator, because that's where my variable is. So I would know that x divided by the sine of its opposite angle, so the sine of 22 degrees, is the same ratio as this side length, 21 2/10 centimeters, divided by the sine of the angle opposite that length. So we'd have the sine of 99 degrees. So if I'm going to solve that equation for x, yes, it's a proportion. I could do cross products. But really, I just need to undo the division by the sine of 22 degrees. So if I multiply both sides by the sine of 22 degrees, x is going to equal 21 2/10 centimeters. I just put that in parentheses to preserve the label, times the sine of 22 degrees divided by the sine of 99 degrees. My equation is solved for the variable. Now I can use my calculator. So, zoom in on it here. I'm going to have 21 2/10 times the sine of 22 degrees. In this calculator, I have to do 22 first, then the sine. Now I'm going to divide that by the sine of 99 degrees, so I have to hit divide by, and then 99 sine, and then hit equals. So notice that to the nearest tenth, x is going to be 8 0/10. Yes, there's a 0 there. No, it's not the same as just saying 8. Because 8 could be anywhere from 7 5/10 to 8 4/10, whereas 8.0 could be anywhere from 8.05. You see where I'm going? 8.0. 7.95 to 8.04. Sorry about that. So x is approximately 8 0/10. If I'm rounding to tenths, even if it's a 0, I need to put the 0 there. Now, it does make sense for my problem. 22 is by far the smallest angle, so the biggest angle has the biggest side. It makes sense that x could be about 8 and 0/10 centimeters, comparing the side lengths to the angle measures. Now, another problem we're faced with, here our directions say solve the triangle. That means find all the missing measures. Well, again, in this one, I have an oblique triangle. I have an angle, angle, side. I can make it an angle, side, angle by finding the measure of angle F. Let's see, 24 plus 19, that'd be the same thing as 23 plus 20. So 43 degrees. So if I take 180 degrees minus 43 degrees, let's see, I have 180, 140, 137. So I've already solved for one missing thing. I know that the measure of angle F is, in this case, exactly equal to 137 degrees. Now I just need to find the measures of these two sides. Well, let's see. DE, E comes before F. Let's find that. So let's see. That's opposite the 137 degree angle. 9 4/10 is opposite the 19 degree angle. So I have enough information here. I know that the ratio of DE to the sine of its opposite angle, so the sine of 137 degrees, is equal to the length 9 4/10 centimeters divided by the sine of its opposite angle, which is 19 degrees. So solving for the distance from D to E, I'm going to multiply both sides by the sine of 137 degrees to undo the dividing. So the distance from D to E is going to be 9 4/10 centimeters times the sine of 137 degrees. All of that divided by the sine of 19 degrees. So if I do that on my calculator, and 4/10 times, have to do the angle first, 137 sine, divided by, have to do the angle first, 19 sine. Now hit equals. So about 19 7/10 if we're going to the nearest tenth. So my value of the distance from D to E is about 19 7/10 centimeters. So I can add that to the things I've solved for. Now I'm just missing the distance from D to F. Well, for the distance from D to F, opposite angle 24, this one I still know. Yes, I found an approximate value for this side, but that's just it. It's an approximate value. So if I use a rounded value in a calculation, I can create error. Might be a little bit off. So the distance from D to F divided by the sine of its opposite angle, which in this case is 24 degrees, would equal the ratio of the two opposite figures that we were given, the 9 4/10 centimeters divided by the sine of 19 degrees. So multiplying both sides of the equation by the sine of 24 degrees, the distance from D to F is 9 4/10 centimeters times the sine of 24 degrees, all divided by the sine of 19 degrees. And so now using the calculator to compute that value, clear that last one off, 9 4/10 times 24 degrees sine divided by 19 degrees sine equals. So about 11 7/10. So the distance from D to F is about 11 7/10 centimeters. And that completes the solving the triangle, because if I knew three things, three measurements, either angles or sides, that means there are three other measurements that we didn't know. So I found the one remaining angle and the two remaining side lengths. That is all for that video.